when you are doing these, sometimes it's good to know different ways of doing it algebraically as well, because graphs aren't always the best method. Or say that it meets at 100, 200, and that's nowhere on your graph, right? It's important to understand that there's other ways of finding the answer. So today we're going to talk about substitution. When you think of the word substitution, what do you guys think about? Think about, we've used this word before. What are some things you think about when you hear the word substitution? Anyone? Yeah. So you take something out of something and you replace it with something else, right? What do you know about those two pieces, though? If you're going to replace one piece with another, what do they have to be?
They have to be the same.
They have to be the same or equivalent. So for you to use substitution, you need something that is the same to replace with the other piece. So that's kind of what substitution is. It's a replacement so that we don't have two variables, because we're dealing with two variables, and it's very difficult to solve an equation when it has two variables in it. So we want to get rid of one of the variables, so we make it a one variable equation to solve. So let's look at some examples here. So let's start here. So the first question is, what do we do when the same variable is not isolated? So when you're talking about substitution, the first thing you want to do always is isolate one of the variables. And make sure it's the easiest one. If that's already done, you don't have to worry about it. Who can tell the class what isolate means? What does it mean when I say isolate one of the variables, Mackenzie?
It's like get it all on the same side of the equal sign.
Yeah, get it on its own on one side of the equal sign. It doesn't matter which side, but getting it alone on one side of the equal sign so there's nothing in front of it like a coefficient or added or subtracted or so a constant. So the next step you're going to do, so we already have variables isolated. We have an x and a y. So we're saying x is the same thing as y minus 11, and y is the same thing as 2x plus 15. So at this point, once you have a variable isolated, you replace the same variable in the other equation with the equivalent expression. So we'll talk about what that means right now. So I'll let you write that down and then we'll do that. Okay, so let's just look at this one. X is the same thing as y minus 11. Do you guys agree that these two things are the same? And we see another x down here. Do you guys agree that that's another x down here? So if two things are the same, we can replace them, right? So we can take this x, that's too big, I didn't want it to erase that much. 1 second. We can take this x, erase it, and what can we replace that x with? What can go in its place, Sarah?
Y minus 11.
Y minus 11. So we can replace this with y minus 11. So one that looks like then is y equals 2 times y minus 11 plus 15. So notice we went from having two variables, a y and an x, to only having one variable. Can we solve a one variable equation? Yeah. Back in there so we know it was there. So then all you have to do is solve this. So Jenny, what would you do first to solve this?
You would plug in the 2 to the y mode.
So you distribute the 2 to both of those pieces and you get 2y minus 22 plus 15. Then what?
So you add together negative 22 plus 15.
So we get 2y minus 7, then what?
Then you would put the negative 2y over.
So we subtract those on both sides and we get negative y equals negative 7. Are you done?
Now you divide by negative 1.
Good. So your next step here is to solve for whatever variable remains. That's the third step there, is just to solve for that remaining variable like we did. Okay guys, think back to yesterday. When you solved by graphing, we were looking for where they intersected. So the point of intersection is having just a y value the answer. No, that's not an ordered pair, is it? It's not the point of intersection yet. So what do you guys think we're going to have to do in order to find that other point? Hannah? Yeah, and it actually doesn't matter which equation you choose. You can plug it into either one, but I would think that the first equation is easier because x is isolated in that one. So what you're going to do then is plug in your solution for the variable. Into one of the original equations. So we'll plug that in next. So if I plug that into this one here, so x equals y minus 11. I plug in 7 for y, and I get x equals negative 4. So the final thing you're going to do is write your answer as an ordered pair. Always alphabetical order. So it always will be alphabetical, so x comes before y, so it's negative 4 comma 7 is our solution. All right, so look at that first example and see what questions you guys have before we do another one. There's a lot of writing on this first page. I won't do that with the next one. Let's see if you have questions. And if you do not, go ahead and flip to the next page so that I know you're ready before I move on. All right then. So it says, what do we do if only one equation has a variable isolated? Well, our first step is to isolate a variable. Do we need to isolate a variable in this first one then? Is there a variable already isolated for us? So do we have to worry about step 1 then? No, because we know that y is the same thing as 6x minus 11. So wherever we see a y in the other equation, it is the same. They're equivalent, right? When two things are the same or equivalent, we can substitute them or replace them. So we're saying we can take this y here and erase it, and it's the same thing as 6x minus 11. So we can replace that with the same thing. Please ask questions if you're confused, because I know this can be very confusing for students. So notice we go from having an x and y in both equations to having just an x to solve for. Again, it doesn't matter which variable you isolate. You just want to isolate the easiest of the two. Okay, so help me solve that, Jacqueline. Right, then what?
Add 2x.
So do negative 2x plus negative 18x, and that's negative 20x. Okay, then what? Very good. Oh, I don't know why I put 20 there. X equals 2, not 20. Please don't write 20. All right, Jacob, so we isolated a variable. We took that variable and replaced it in the other equation. We then solved for the remaining variable. What is our next thing that we have to do? Which equation would you want to put it into? The first one. It's a little bit easier, and the first one a little bit less solving. So we're going to plug it into the first one. Does it matter which one you do? No. But I always try to find the easiest one. So we know x is the same thing as 2. So y equals 1. But you're not done yet. What is the last thing, Spencer, I want you guys to do? So what is my ordered pair? I got 2 comma positive 1. Did you have 12 minus 11? Okay, good. Just want to make sure we were in the same place. That's all good. You're just tired, Spencer. It's all good. I understand completely. All right. Any questions for me on that one before we move on to the next one? All right. I'm going to make sure you guys are all good. I think some of you guys are just moving on, which is completely fine. I just want to make sure that we're in the same place here. Okay. So the next one says, what do we do when neither equation has a variable isolated? So neither equation has a variable isolated. What do you guys think we're going to have to do? Isolate a variable. So Alex, which one do you think would be the easiest variable to isolate?
2y.
Which 2y?
The bottom one.
So you want to isolate y in this one?
No, x.
You want to isolate x in the bottom. Why would that be the easiest one to isolate?
Because x doesn't have anything next to it.
It doesn't have a coefficient, right? It doesn't have a number in the front of it, which means you're never going to have to divide. So look at this. If we were to move this over, we'd have to divide by -7. That would give you guys some fractions. And the last time I checked, you guys are not fans of fractions for most of you. So we want to try to avoid getting fractions in things. So when there's no coefficient in front of the variable, that's the easiest one to isolate. So Alex, how would I isolate that x?
You add 2y to each side.
So you can't replace until a variable is isolated. So we have an isolated variable. We know x is the same thing as 2y plus 11. And in the first equation, because you have to you have to look at the other equation. You can't substitute back into the same equation. That won't work. So make sure you're not substituting back into the same equation. If you did that, you're going to get the answer wrong. So we know that x is the same thing as 2y plus 11. So I can erase my x and replace this with 2y plus 11. So that becomes -7 times 2y plus 11 minus 2y equals -13. So all I did there is I replaced the x there that was the same with 2y plus 11. Avery, go ahead and solve that for me. Tell me how to get to it. Don't just tell me the answer.
So distribute -7 with 2y and 11.
Good.
And you have -14y minus 77 minus 2y equals -13.
Then what did you do?
And then you add 77 to both sides.
Okay.
You get -14y minus 2y equals 64.
Okay.
Then you subtract, or you add -2 and -14y. You get -16y equals 64. Then you divide by -16. And you get y equals -4.
Very good. Morella, are we done? What do we have to do now?
Plug it back in.
Which one do you want to plug it into? First or second?
The second one.
The second one does seem easier, doesn't it? So we're going to plug it into second one. Again, it doesn't matter which one you plug it into. So I know that y is the same thing as -4, so I plug in -4. So I get x plus 8 equals 11. Subtract 8 on both sides, and I get x equals 3. So, Alexis, that's not how I write up my answer. What is my actual answer? Perfect. I thought you had 4 equals 4 somewhere. That's a y, though. It looked like a 4 to me, so, but I was just glancing at it. All right, any questions there? Okay, this is like the most challenging situation for all of you guys when it should be like the easiest one. And I have no clue what it is about when the same variable is isolated. So we have y equals 2x plus 4 and y equals 2x minus 3. What do we do? Avery?
Would it be no solution because they're different?
You are right, they are going to be no solution, but let's prove that through algebra, okay? You aren't wrong with that. What are we going to do?
Plug them into each other.
You kind of can just set them equal to each other. We know that y is the same thing as 2x plus 4, right? Well, and this is y here, correct? So I can take that y and replace it with 2x plus 4. So I get 2x plus 4 equals 2x minus 3. So you kind of get to just set them equal to each other because you're saying they're the same thing. So you get to set them equal to each other. So Katie, go ahead and solve that. What would you do first?
Subtract the 2x.
And what do you notice happens, Katie?
It doesn't equal 3.
Yeah, 4 doesn't equal -3, so as Avery said, it's no solution. Now, Avery, I would be completely fine with you writing no solution from the start. Okay? I'm just showing this so that we understand what happens when the variable cancels out. So this is no solution. What if it had come out to 3 equals 3? It's true, so what do we say? What'd you say? Yeah, all real, which I started thinking about it yesterday. That really doesn't really make sense because not every point on the coordinate plane doesn't really make sense. But if you wrote that, I'm not marking it wrong. Infinitely many makes more sense. So if you write infinitely many solutions or all real, I'll take both answers. All right? Infinitely many does make way more sense when it comes to this situation, though. So infinitely many, I just spelled infinite wrong. And like I said, I'll take both answers. And I am fine with you guys writing IMS for infinitely many solutions, okay? So if you want to make it shorter, go ahead and do that. So what if you get the same thing equals the same thing? That means infinitely many solutions, all right? I do want to get through some word problems with you guys because word problems are like the death of you guys, I'm pretty sure. Sometimes you see words and you won't even read them. You're like, I'm just not going to be able to do this, so why even read the problem? So let's try to avoid that. I want you to try. All right, so at the end of the 2010-2011 football season, 45 Super Bowl games have been played. The National Football Conference has won 3 more Super Bowls than the American Football Conference at that time. How many Super Bowls has each conference won? So, the first thing I want you guys to do is to figure out what your variables are. So what are my variables? Because we're going to have more than one. We're finding 2 separate things. So Mackenzie, what are the 2 things we're finding?
The number of Super Bowls for one from the NFC and one from the AFC.
So I'm going to call them N and A just because that makes the most sense since it's NFC and AFC. So that's the number of Super Bowls won by the NFC. I think you can go at 8:10 if you want to. Okay. And then the other one is the number of Super Bowls won by the AFC. Okay, so let's reread this problem. So I'm going to kind of highlight some important information here. At the end of the 2010-2011 football season, 45 Super Bowl games had been played. So that 45 there seems kind of important, doesn't it? That there's 45 Super Bowl games played, since we need to know how many each person has won, so they have to total the 45, right? That's what this is saying, that when you're thinking about the number of Super Bowls by the NFC and the AFC, they have to total the 45. Are there ties in the Super Bowl? No. So there's not going to be, it's going to be an exact 45 between the 2 of them. It says that the national One second. It says that the national has won 3 more Super Bowls than the American, which seems important too, that there's 3 more Super Bowl wins there. So those seem to be the big things. Whenever you have 2 variables, you need 2 equations. So you're not just writing 1 equation, because if you don't have 2 equations, you're never going to be able to solve it. So whenever you have 2 variables, you need 2 equations. So let's start with the first one. There's 45 total Super Bowl games played. How do you think we could write an equation for this one here? How could we write an equation for that, Sarah? We're saying that the number of Super Bowls that the NFC has won plus the number of Super Bowls the AFC has won has to total 45, right? That's what that's saying there. If you were to say it in an English sentence instead of opposed to a math sentence. So this is going to be equation 2. So the NFC has won 3 more Super Bowls than the American Football Conference. How could we write that equation? Okay, Kelly, what are you thinking?
N equals A plus 3.
So let's make sure this makes sense, because a lot of you guys are going to do N plus 3 equals A. Is what I'll see a lot with you guys. So you need the NFC to have more or less than the AFC. If the NFC has won 3 more Super Bowls, will they have more or less wins? More. So if I were to plug in just a random number, if I were to plug in and say the AFC had won 2 Super Bowls, how many Super Bowls would the NFC had won? 5. So are they winning more? So does that make sense? So always go back and check that yours makes sense, because I see a lot of it as A plus 3 or N plus 3 because they're right next to each other, but that implies that the AFC has won more. All right, so now we can use what we just learned today to solve this. We see that N is the same thing as A plus 3, and there's an N up here, right? You guys see that? So we can take the A plus 3 and plug it in for the N. So I get 2A plus 3 equals 45. So I get 2A equals 42. So A equals 21. So how am I going to figure out how many games the NFC has won? Yeah.
You can just add 3.
You just get to add 3 to it because it's N plus, or sorry, not N plus. N equals A plus 3. So we know that A is 21, so 21 plus 3 equals N, which is 24. So since it starts as a word problem, you need to write your answer up as a word, like as a sentence. So you'll say the AFC has won 21 Super Bowls. And the NFC has won 24. All right, look at that and see if you have questions for me before we go on to the back page. So we're just going to do example 6 and we'll skip example 7. So when you guys are done. Please ask questions if you have any. Please, 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 on your homework, just try the word problems no matter what. I know they're intimidating to some of you. Put something down. Try to make the 2 equations. Try to define your variables. Do something with it. Does that make sense? I need you guys to try or else we're never going to be able to learn how to do it. Okay, a bookstore that sells books and magazines just opened. They sell books for $12 each and magazines for $3 each. In the first week, the store sells 55 items. The sales total $345. How many books did the store sell, and how many magazines did the store sell? So let's start by defining our variables. What are my variables in this case? Jenny? What'd you say? And what do you want B to be? The number of books sold? And what's M? Okay, so here's one of the equations. They sell books for $12 each and magazines for $3 each. And then it also tells you in the first week they sell 55 items. And then you have this other number over here. They sell a total of $345. Which equation is that going to go with? Equation 1 or equation 2, and why? Which equation do you think that one goes with? Because we usually only write 2 equations, and which one do you think it will go with? Jill?
Wait, did you say for the 345?
Yeah, we'll go with equation 1 or equation 2.
Yeah.
Why?
Because that is dealing with the amount of money, the second one is just saying how many items.
Thank you. It's very important you realize that. You need to keep the same kind of units with the same kind of units. So she's keeping money with money. So equation 1 deals with the prices of the items, right? And 345 is a price. Whereas the equation 2 is dealing with the number of the items. So it doesn't really make sense to put money with the number of items. So you always keep the same units with the same units. I know it sounds weird for me to say, but that's exactly what you're looking at there. So, Kaylin, help me with the one that's green, the equation 1. How would I write that? They sell books for $12 each and magazines for $3 each, and it totaled $345.
12B plus 3N equals 345.
Perfect. You have, we're saying here it's $12 per book, right? And $3 per magazine. If you add those numbers together, you're going to have a dollar amount plus a dollar amount to get the total of $345, which is a dollar amount. So that makes sense that that's all together. Carly, they sold a total of 55 items. How would you write that up? Books, the number of books sold, plus the number of magazines sold have to come out to be 55. All right, one of our variables is an isolated, right? So the first step we have to do here is isolate a variable. So I'm going to isolate the b there, so I'm going to subtract m. If I'm ever standing in your way, just let me know. So we know b is the same thing as negative m plus 55, and there's a b up here that we can replace that with. So I have 12 times negative m plus 55 plus 3m equals 345. So I distribute. Can somebody do, does somebody have a calculator? Avery, you do. Can you do 12 times 55 out for me?
660.
Did you get 660 as well? Okay. I always double check. Otherwise I do the whole entire problem wrong. So then we have negative 12m plus 3m, which is negative 9m. And then I subtract 660 on both sides. What is that when I do 345 minus 660? Did you do it already, Jacob, too?
Yeah.
What did you get?
Negative 315.
And did you get the same thing? Yeah. Okay. So we divide by negative 9. And we get m equals, so that 9 goes in there 3 times with 4 left over, so 45. So is it 35? So we have 35 magazines. And how can we find out the number of books, Kelly? How could we find out the number of books?
Plug in for B.
We don't want to plug in B because we don't know B. We want to find B. We know M, so we need to plug in for M. And which equation do you want to plug it in for? The top one or the bottom one there? That red one or that gray one?
The grade.
The gray one seems a little bit easier, doesn't it? So we have B plus M equals 55. So M is the same thing as 35. So I get B equals 20. So they sell 35 books. Oh, sorry, 35 magazines and 20 books. All right. So again, word problems aren't the easiest because you have to come up with the equations on your own.